Today we're looking at the EG4 LiFePO4 battery. I've got these installed in my RV right now, along with a DIY battery. These 48 volt 100 amp rack mount batteries are 5.12 kilowatt hours. They can run closed loop with the 6000 XP. They've got some monitoring built into them for the standard RS485 and CAN bus. We'll go through that. We're going to hook them up, show you how they hook up in parallel. We're going to show you the built-in breaker that'll save you a fortune. We're going to talk about mounting them in the RV and how I went through that, connecting them to the 6000 XP, and last but not least, we're going to handle the wiring so that you understand how they're connected and why they're connected that way. Hang on, here we go. It's going to be a great ride. These are my EG4 LiFePO4 batteries. As you can see, I've got Solar Assistant connected directly to them because I don't have the closed loop hooked up to the inverter at this point. I like the way the Solar Assistant shows stats, which I'll put on the screen here so that you can see them. I like the way it breaks up the batteries, kind of like the more modern versions of their batteries do, and give you all the stats of all the cells, the high voltage, the low voltage, the average voltage. But as you can see here, I have these battery cables come in from the bus bar on the other side. They come through this piece of plywood, which is basically mounted on the other side is the EG4 6000 XP. And it runs from that bus bar into here. They connect to the positive terminals here. And these batteries also have breakers in them, which is really nice because then you don't have to go out and buy breaker switches and fuses and all that kind of stuff. They're 100 amp hours a piece. 100 amps a piece. Talking batteries, I talk 100 amp hours. 100 amps a piece. Negative wires down here. These are 1/aught marine grade 105 degrees Celsius wires. They're a little oversized, but I like doing it that way on all my battery cables. That way I'm sure that even if the system goes down to one battery, it can handle the amperage. Now these are 275 amp cables. One of these wouldn't be able to handle it. Two of these wouldn't be able to handle it, but I at least feel safe that I know I have the right size cables here. You can see here I do have them daisy chained together, and they do communicate through the standard cable that came to connect to the EG4 software to Raspberry Pi Solar Assistant. Now, this wire could run all the way up into the RV, into to where I keep my other equipment, and it will at some point. But I wanted to configure it here and make sure everything was working, and it does work, so that's good. But you could also connect these batteries, and you'll see the communication cable here to go closed loop with the EG4 6000 XP, which is their inverter for, and if you haven't seen that video, I'll link it here also. But it gives L1, L2, 3000 watts each side, 6000 watts total. The PV runs in through here. But I have mounted them here, as you can see, and I'm gonna cut this and kind of go around and show you this mounting bracket right here, which is how I've got them mounted in here. All right, so this is around the back. And in the back you can see that bracket is bolted directly to the 2x4 there, and then is welded here. You can see my welding was not very good at that point, but it's basically just a metal box that's attached to the wood on this side. Now, unfortunately, I don't think in the case of a major accident that would do a whole lot to stop these batteries from moving around. But it does good enough to hold them in place under normal circumstances. Now let's go take a look at the inside where the bus bars are and how they connect electrically. So in here, this is the bus bar where the 3 EG4 batteries come in. This fourth wire here goes off to the DIY battery. And this is the negative bus bar 1, 2, 3 EG4 batteries, and the negative coming off to the DIY battery over here. The negative runs through the shunt. See if I can get this wire out of the way. I've been moving some of these wires around. Runs through the shunt over to the bus bar here, the distribution bus bar, and then over to the 6000 XP, where again, you have a breaker here for on the inbound side for a 200 amps. And then each breaker in the batteries is 100 amps. So it keeps the batteries from too much being pulled from them, and this keeps it from too much overall. I also have a 250 amp A&L fuse here in the positive side before the power distribution positive. That runs off for the DC side. This runs off to the AC side for the 6000 XP. But as you can see, it's very simple. Positive comes in here to the positive distribution, down a little bit. Negative comes in over here, goes to the shunt, to the negative distribution. And that allows me to connect things like the extra charger that's used for the solar shed, or when I'm traveling is used for the portable panels, or a DC distribution to run on the other side of the unit, the Orion TR4812s, which convert the 48 volt down to 12 volt and eliminate the need for a 12 volt battery. It also allows me to run things like these DC fans, and all of the regular RV DC stuff is just ran straight in here. As you can see, I just took the output of these that used to connect to the 12 volt battery and ran it in there. So those EG4 batteries, even when the power is out, those EG4 batteries run everything DC side. Closed loop and monitoring through the RS485 or CAN bus are two closely linked items, and I'm going to cover them kind of together here. So closed loop is when you take the batteries, as I demonstrated earlier, and you connect them together with a cable, and you plug that directly into the inverter, and that allows the inverter to understand the state of charge of each of the batteries and to monitor them and provide what those batteries need as far as a charging profile, or as far as the current, or as far as kicking on generators, or reacting to their state of charge independently of other configurations and other ways of doing things. Now, I use a monitoring system. I control my charging and all of that through the voltage, and it's called open loop. And I don't use the state of charge from the batteries. I've found that the batteries are widely vary in that. And then when I added a DIY battery, it kind of made it to where everything was based on what was going on with those three batteries as opposed to my DIY battery also. So I changed this to use state of charge. It also eliminated some problems that I was having with the 6000 XP's minimum percentages of you can't run the battery past 10% without it kicking on the grid, or putting it into end of day mode. And I didn't want that either. I wanted to control what those voltages were and use my full battery capacity. Now, that said, I do monitor these things, and I do trigger things based on them, very similar to what happens with the 6000 XP. Let me show you from the computer screen. This is what I am using, which is Solar Assistant. Solar Assistant plugs directly into the batteries, and I should be able to show you a picture of that, or have already showed you a picture of that, where instead of those daisy-chained batteries going to the inverter, those daisy-chained batteries go to the Solar Assistant. I use the same cable that is provided when you buy the EG4 batteries to connect your computer. I use it to connect the Solar Assistant, and it works just fine. Now, I do want to show you a little bit about the configuration and how it works. The numbering of the batteries is a bit different. So in the case of that you are working with in the case that you are working with, if you're working with Solar Assistant, you want to start the numbering of those batteries at 1 and go 1, 2, 3, 4. If you are working with the inverter, you want those batteries to start at 0. So it'll be 0, 1, 2, and 3. And therefore, that's how it identifies. And this is something I learned as I was going through and configuring this. So let me show you on this configuration screen how you can change the setup. So normally, and I'm just going to disable this here so that you can see me working with the live system. So this would normally just be set to use the inverter's values. And if you use the inverter's values, then it's going to pull those values from it. And if you're in closed loop situation, then that's what you would want to do. And it will pull, when it pulls the values off of the, in my case, the 6000 XP or the Lux Power inverter, whichever inverter you happen to have connected, it would also pull the battery contents and put them there. But in my case, I decided not to do that. So I went down here and I picked the USB NARDA RS485 connection to the same EG4 batteries. And they plugged into that USB port using that same adapter that came with your batteries. They allow it to read that directly. So if you'll see here, if I hit connect, you'll see it cycle through, going through and looking for the batteries, finding out what baud rate, where they actually are located, no response. And then all of a sudden it says, oh, discovered battery 1, 2, and 3, and whammo, it's connected. Once it's connected, now the battery status out here in Solar Assistant is using those batteries, those 3 batteries that it located, and you can see the status of each one as reported through the RS485 connection, or the same connection that would be sent to the 6000 XP if, or your inverter, if they had been connected with closed loop. Now, I don't like the way that the 6000 XP summarizes my LiFePO4 batteries, the V1 batteries, to just this content right here at the top. So I do appreciate the fact that this has all of the content about the batteries, the cell voltage, the high cell, the low cell, and as you can see, they are all relatively well balanced, and they do remain that way. Now they do have an alarm today. It's alarm 94 is basically because they're below the state of charge of 20%. Last night was the last few days have been very rough with weather around here, and so I've been recording a lot because the sun hasn't been out. At the same time, there's been a lot of power shortages because of that same problem. So that is how you can use the Solar Assistant to run your batteries and to report that. And then that reports into Home Assistant and pulls all of my batteries together. But the important thing here is to understand those batteries do run in closed loop. And if you wanted to run them, if you have them connected in closed loop, then you would just change this to the option of use the inverter settings. And when you do that and you connect it there, all it's going to connect is this here, and it's going to pull the state of charge directly from what the inverter is reporting as opposed to what the batteries that I have connected to it. A Solar Assistant allows for a little bit of flexibility in how you can connect these, and this is the method that I chose. So here we are in the RV, and we're taking a look at the batteries and how they are connected currently through the Solar Assistant. And I'm going to switch them to closed loop so that you can see them in 6000 XP. So you can see here they're labeled. This is battery 3, this is battery 2, and this is battery 1 with the dip switches all currently. And then this is wired through, this comes out and runs around and goes into the Raspberry Pi here, which is controlling the Solar Assistant. Now, what I'm going to do is I'm going to change this. I'm going to disconnect the communication here to Solar Assistant, and I am going to switch these batteries numberings. So this one needs to be battery 0, this needs to be battery 1, and this needs to be battery 2. So if you'll look now, you'll see that is 0, all switches off. The first switch's value is 1, so we add that into it, and that gives us a value of 1. And in this one, the second switch's value is 2, and we don't have a 3, so we don't need to put the first switch and the second switch on together to add up to 3. And you can see that the alarm light is still flashing from them having a low charge. Now, this cable, and we're going to go over to the 6000 XP and I'm going to show you how to connect it. But this cable, it came with the 6000 XP, and it is the battery communication cable, and it plugs in the same as the connector for the solar assistant. It plugs in here and then it runs through the wall to the other side. So we'll go over there and take a look at that, and we'll show you how to configure it on the 6000 XP. Here we have the 6000 XP panel. I just want to make sure I position this where you've got a good view of how it works. And you can see the cable comes in here and runs to the 6000 XP. Now let me show you, pull this panel off and show you where this is connected. And as you can see here, it gets plugged in at this first location here, which if you look down at the bottom says that this is the RS485, 485A, B, CAN bus and CAN switch. So it's also the battery COM is how it's labeled at the very bottom. So we are going to plug that in here. These two are used for paralleling with multiple 6000 XP, so we don't need to use them, but we do need to plug this in here. Now for the configuration on the 6000 XP, we will need to change it, because if I'm using open loop, it is different from closed loop. So here's what I'm going to see if I can get this without a glare for you. Okay, so I think I got this where we can do it. You have a little bit of a reflection, but for the most part, you can see what's going on here. So as you can see, I have power coming in up here, and it says that I'm running lead acid down here with 1.2 kilowatts going in to the battery. You can see that with the arrow. So that is the key symbol here, is that it's running under lead acid, and you don't see a state of charge anywhere. Even when I cycle through this, it says that I have 53.5 volts, I have 1.1 kilowatts running in, and I have 53.4 volts. So it basically has no information. So what I'm going to do is I'm going to push and hold this and go into program mode. And then I'm going to go up to the battery setting, which is here. I'm going to hit enter, and I'm going to change the battery type to lithium iron, hit enter, and then it's going to ask for the battery type. Now for EG4 LiFePO4 batteries, or your EG4 batteries, it is type 0. So I'm going to change this to brand 0, like this, and then I'm going to hit enter, and I heard it click, and you can see it switch to the grid. And that is why it immediately switches over to the grid, and because it doesn't know that it has a battery, you'll see that the battery has shut off, and so the PV is not going in because it is in bypass mode as it's determining communications with the battery. So we're going to give this a few seconds, and it should go out and communicate with those batteries. So you can see there, it realized that there is 300 amp hours of batteries. It has 52.6 volts. It's getting in 16%, I'm sorry. And now the PV is starting to ramp back up, and you can hear the PV coming in again, and it's turned off the grid. So as you can see, that is a very simple. Now, though it still has a warning over here, the warning is because now it's registering this state of charge as being under 20%. So when that goes over 20%, that warning will come off. And this is a configuration that you can set, but you can't set it as low as you would like to. You can see it's normal operation with a warning, and I can tell you the warning is this 16% right here. So that is switching it to closed loop. Now, if you want to switch it back from closed loop, which I'll demonstrate that also, because I am going to go back to not being in closed loop, you'll want to go back into program mode, go back up to battery, hit enter, go to lead acid. There's either lead acid, no battery, or lithium iron. Lead acid basically means that it's going to use the charging profile that's stored in there for lead acid, meaning what voltage do I charge at and all that kind of stuff. So we're going to go to lead acid. We're going to set the amp hours, and in my case, that's 600. And then we're going to Notice that it says it's battery, and we're going to say okay. Come back here and it says it's in lead acid, and it's got 53. And for this one, it didn't need to shut off the power when it switched here. If your batteries are in closed loop and it doesn't register a battery, regardless of what voltage is there, it doesn't know what to do. It doesn't know if it can charge it. It doesn't know if it can discharge it. It has no communications with the battery. So better safe than sorry, it switches to grid power and shuts the power used from that battery down in order to be safe. So that is why we saw it shut down when we went into mode, into closed loop, but we didn't see it when we came out of closed loop. So now that we're out of closed loop mode, everything will go back to normal operation, and I can go back to the other solar assistant and reconnect it, but I have to change the switches. Okay, so here we are back at the batteries again, and it's easy to come off of closed loop. I'm just going to disconnect the COM port, which is no longer being used, and I'm going to change the battery numbers to 1, 2, and 3. And the way this works is the first one is worth 1 point, the second one is worth 2 points, the third one is worth 4 points, and 8 points, and you just add them up. So we have 1 and 2 turned on, which adds up to 3. We have only 2 turned on, which adds up to 2. And we have only 1 turned on, which adds up to 1. If I needed to register battery, let's say 7, I would have to turn on 4, 2, and 1, and those would add up to 7. 8 would only be this fourth switch because it's 8 all by itself. 9 would be the fourth and the first switch because 1 and 8 adds up to 9. So that's how these dip switches work. Now that we have all of that done, we're going to plug it back in to the solar assistant, and then I'll take you back inside and show you how it reconnected. Okay, so you can see here, solar assistant is still up and running on the screen, and I'm going to scroll down here to where we had it connected, and you can see it's registering that it is connected. This is pretty reliable now. They did a couple of upgrades in last year that really tidied up this really nice and well. If it says it's connected, it most likely is connected, meaning that it reestablished connection from being down. Now, the easiest way to check is because we do have statistics coming in from the batteries, is we can just go click on the batteries themselves, and we can see if the wattage, I can see the wattage changing and the amperage changing. Or you could look at each individual battery also and see 322, 6.10 amps, 6.20 amps, 327, 327, and 6.2 here. We'll give it a second. It should probably change a little bit. It's got voltage coming in. There it goes, 322. And come down here to the third battery. It's at 322 at 6.1 amps. And give it a second. There it goes, 312 at 5.9 amps. So it is communicating with all 4 batteries. And as you can see, well, it's pretty obvious that the EG4 LiFePO4 batteries have a lot of advantages. They're very conveniently packaged up and given to you in 100 amp hour blocks. They're nice and tidy. You can mount them on their side like this or flat. The newer versions have multiple battery terminals so that you can connect them in parallel. That's really a good thing. These I ran to a bus bar, so it didn't make much difference. But it's also nice that they all have breakers on them. 100 amp hour breakers, believe it or not, it's kind of expensive to hook your batteries up on breakers if you don't have them. They run in closed loop with the EG4 6000, the EG4 12K, the PV 12K, the 18K, a lot of different EG4 inverters and stuff. So there's a big advantage there. They run with the solar assistant with the RS485, which probably means that most inverters that support the Pylon protocol will also work. So I could see that as being a huge benefit. The lights on the front make it easy to determine, you know, where the basic level of where the batteries are, which ones you're having problems with the blinking light like I'm having today, just low battery, kind of, hey, pay attention to me kind of thing. Makes it easy to see it in a glance. Um, the switches, uh, the V1 here only allowed up to 16 in parallel, but they've obviously gotten around that because the newer versions allow up, I think it's up to 64 that you can go to. So that's great. They come with the little cables to connect one to the next, and they come with the cable to hook up to your inverter. So these guys have everything in a great, convenient little package. They work really well. They've been as solid as a rock. Um, Paralleling them has not been a problem. Um, Monitoring is not an issue because if you're going closed loop, you're right smack dab in the middle of the inverter itself has the data. And if you're not closed loop, then you can do like I did and do a solar assistant or some other type of RS485 CAN bus type connection. The wiring is simple and easy. They come with wires, and there's also racks that you can get for sets of 3 battery or sets of 6 battery. I'll include pictures of those and links in the description for them. All around, it's a good, rounded, solid battery. And so I'll leave you on that. I hope this has been helpful. If you have any questions, please leave them in the comments below. I'll be glad to answer them. Other than that, we'll see you on the next video. Thanks for watching.